All right, so it's finally time to get into some multivariable stuff. 31a, we are going to determine if this function of two variables, x and y, is additive. Now, the thing about it is this notation over here, discussing additivity and defining additivity, says for any two elements x and y of its domain. So what are the things in the domain of a function of two variables? The things in the domain of a function of two variables are pairs of numbers. So, you might want to generalize your notion of what is in a domain and say that, look, in general, we're going to have things that are vectors in the domain. I used to denote vectors with harpoons, put harpoons above them. And so you want to think of all these things that you can put in to F as vectors of various kinds. In green and in red. So we need to think of x as a vector containing two things in the case of a function of two variables. And so I will take the particular vectors x harpoon and y harpoon. X harpoon will be 1, 2. Okay, let me put this back down here. See, I am looking at a particular x harpoon and y harpoon, these two vectors. X harpoon will be 1, 2, y harpoon will be 2, 1. And I'm going to examine f of x harpoon plus y harpoon and f of x harpoon plus f of y harpoon. Okay, so I'm going to compare those two things. And this particular function takes in two vectors and gives out one component vectors or just numbers. Okay, so as you can see, I've done the calculation, and indeed both of these give 15. This is going to be additive, but I want to draw a picture to go along with this. This right here is 1, 2 over 1 up 2. That is what we'll call x vector. And y vector, the second term in there, I'm going to make that in blue. That's 2, 1, go over 2, and then up 1. That'd be an arrow that ends there. Okay, so this is the picture in the domain. Y harpoon sits right there. And then also I need to draw x plus y in the domain, and let's see, that would be the vector 3, 3. So 3 and 3, I'd draw the tip of this guy right there, and that is x vector plus y vector. And now I need to draw the output associated with all three of those inputs, and they all go on a copy of the number line. Okay, the domain of this function is the plane, right, the set of all ordered pairs of numbers, and the codomain is this real number line. So let me think for a second about how long this number line needs to be, what kind of numbers need to be in there. I need to have, say, the number, 15 needs to be in there. That's the biggest thing that's going to be in there. So let me do 0, 5, 10, 15. Okay. And f of x, let's take a look at that. That's f of 1, 2. That's 3 times 1 plus 2 times 2. That's 3 plus 4, that's 10. Is that right? 4 and 3. No, that's 7. Okay, 7. So 5, 6, 7. And f of x is 7. Okay, so there's f of x vector, where x vector is 1, 2. And then in blue, I'm going to draw the thing that y gets turned into. Y is 2, 1. F of 2, 1 is 3 times 2 plus 2. Let's see if I can get my arithmetic right this time. 3 times 2 is 6 plus 2 is 8. Okay. So I'll make another tick mark here. 8. And in blue, I will draw an arrow and call that arrow f of y, harpoon. Okay, now again, the harpoons are on there so that you're not thinking that this x and that first component of x are the same thing. No. So x harpoon is a pair of numbers 1, 2 that you would call a value for x without a harpoon and y without a harpoon. Okay. Now I also need to draw the image of the green guy. Let's see, what does that look like? F of 3, 3 is 15. So in green, I'll draw this. Arrow out to 15. And that is f of x plus y. And then I have one last thing to draw from the list of characters. All right, there's the 3 things in the domain, and then the thing that each of them is mapped to, and then the red vector, the odd guy out, the sum of the images. The sum, where did that red pen go? There it is. So right here, I want to say the sum of 7 and 8. That is, oh, it's 15. So I draw another red arrow all the way out there and make it really big so you can see where it is, and say that's f of x plus f of y, which isn't necessarily the image of anything over there. There's nothing drawn in red over there, but it coincides with f of x plus y. Okay. And let's now get to the end of this similarly. All right. For arbitrary ordered pairs, x1, y1, x2, y2. Okay, now those are ordered pairs because, say, 1, 2 is an ordered pair. It's different than the ordered pair 2, 1. See, order matters. 1, 2 and 2, 1 are not the same thing. So that's why I call them ordered pairs. So for arbitrary ordered pairs, f of x1, y1 plus x2, y2 is, well, that's f of x1 plus x2 using the rule for 2-vector addition. y1 plus y2 is the second component, and then we have 3 times the first component, x1 plus x2, and we have 2 times the second component, y1 plus y2. And f of x1, y1 plus f of x2, y2, well, that'll be 3 times x1 plus 2 times y1, right? I'll put parentheses in there to make me think, yeah, I'm just looking at this first term, and then this term over here is 3 times x2 plus 2 times y2. And of course, I can collect like terms, the terms that both have 3's in them. I can say, I can factor out the 3 from those 2 terms to give me 3x1 plus x2. And the terms that have 2's in them, I can factor out the 2 and get 2y1 plus y2. And that is exactly the same algebraic expression as that. Okay. So, since that equation here holds for any 2 things in the domain of f, f is indeed additive.